Welcome to another video on binary trees. Today we will look at representation of binary tree using array. Right. So this is, as you can see, this is a binary tree. This whole thing is a binary tree where each node has at least 0 or 2 nodes. Right. But the point is, this binary tree is not a complete binary tree, right? Because here, as you can see, for D there is no left and right child nodes. If you want an explanation about complete binary tree, you can actually see my previous videos where I have explained about a complete binary tree. So this is not a complete binary tree. So to make it a complete binary tree, you just need two blank nodes here, the left blank node and the right blank node. Once you have these nodes, this binary tree becomes a complete binary tree, right? So how do you represent this binary tree as an array? So this is level 0, this is level 0, right? This is level 0, this is level 1, this is level 2 and level 3, right? So here 0th level we just write A. For level 1 I go from left to right, B and C. For level 2 I go again from left to right, D, E, F, G, D, E, F, G. Now I leave blanks here because there are blank nodes, right? I leave blanks here and then I say H and I, right? So this is how I represent a binary tree in the form of an array, right? So now if I consider an element at index I, suppose for example, let us take let us take the element called E. So let us check where E is. E is at index 4, right? So I equal to 4 here. So for example, E is at index 4. So first point is, what is the left child of E? Left child of E is equal to, let's use the formula here, 2 into, right? E is at index 4, right? 4 plus 1, that is 9. Again, right child. So let us check whether actually this is right or wrong, right? So here I am saying I got an answer called 9. So what is at index 9? At index 9 we have H. So this is nothing but H here. So is H the left child node of E? As we can see in the tree, H is the left child node of E. Therefore this answer is correct, right? So what is the right child of E? Nothing but, let us use the formula, 2 into 4 plus 2, that is 10. Let us check what 10 is. 10 is I, right? So this is nothing but I here, and let us check the tree here. Yes, I is the right child node of E. So our answer is right. So now let us check what is the parent of E. What is the parent of E? So here for this formula we have the floor value, right? We have the floor value where floor of I minus 1 by 2. So now E is at index 4, right? So I will say here 4 minus 1 by 2. It is nothing but floor of 4 minus 1 by 2, that is 3 by 2, right? 3 by 2, that is 1.5. The floor of 1.5 is nothing but 1. Nothing but 1. So what is 1? Let us check what is 1. 1 is nothing but B. 1 is nothing but B. Therefore, the parent of E is nothing but parent of E is B. Parent of E is B, which is right, as we can see in the binary tree, right? So we have seen how to calculate the left child of a particular node, right child of a particular node, as well as the parent of that particular node, right? Parent of that particular node. Right, now let us look at another example. I have drawn the same thing here as well. Now let us look at B. Let us look at B. Let us see what the left child of B would be. So left child of B. First let us check what is the index of B. The index of B is nothing but 1 here, right? 1. Therefore, here let us use the formula 2, right? So 2 into the index of B is 1, 2 into 1 plus 1, that is nothing but 3, that is nothing but 3, right? So here the left child of B would be 2 into I. 2I is nothing but the index of B, right? So 2 into 1 plus 1, 2 plus 1, that is 3. So what is 3 here? 0, 1, 2 and 3, D, right? So here 3 is nothing but D, and let us check whether this is right or wrong. Yes, so basically here the left child of B is D, so this is correct. What is the right child node of B? 2 into 1 plus 2, right? That's nothing but 4. So let us check what 4 is. 4 is nothing but E here, right? So this is nothing but E. Let us confirm with the binary tree. Yes, E is the right child node of B, right? So here this is right and this is also right. So what is the parent of B? Parent of B, we know the formula, I minus 1 by 2, right? So here I minus 1. So basically here we have to say what is the value of I here? 1. 1 minus 1 by 2 is nothing but 0 by 2 is nothing but 0, right? 0 by 2 is nothing but 0. So what is there in the 0th index? A. So A actually is the parent of B, right? A actually is the parent of B. So this is right with respect to binary tree, right? So here the formula for the parent of a particular node is I minus floor of I minus 1 by 2. Here the value of I is 1, 1 minus 1 by 2, 0 by 2, that is 0, which is nothing but A in the binary tree. Now let us look at one more example. What is the left child of F is equal to, we know the formula. Let us look at where F is. F is at index 5. So 5, so here I say 2 into 5 plus 1, that is nothing but 11. So where is 11 here? There is no node or there is no element at 11. As we can see in the tree as well, there is no element, there is no left child of F. Therefore this is also right, right? So there is no element at 11. What is right child of F is equal to, same thing here, 2 into 5 plus 2, that is nothing but 12. There is no element at 12. As we can see here, there is also no element for, there is no right child for F. Therefore there is no right child for 11, sorry, there is no left child for F, and there is no right child for F, right? So we got the answer as 11 and 12, but there are no elements here in the array for 11 and 12, right? So what is the parent? What is the parent of F now? What is the parent of F? We know the formula here, floor of I minus 1 by 2, floor of I. So we are talking about F here. So F is located at index 5 here, right? So here I am saying here 5 minus 1 by 2, right? 4 by 2, that is 2. Therefore the parent of F is at index 2. So what is at index 2? C, right? C, correct? So in C is at index 2. Let us check with the binary tree whether this is right or wrong. The parent of F is C, correct? Which is right. Therefore here the left child of F, we don't have any element at F, right? Left child of F. Therefore there is no left child of F in this binary tree. There is no right child of F in this binary tree, but there is a parent of F. The parent of F is nothing but 2, and 2 we have C here, and we confirm it with the binary tree as well here, where C is the parent of F. Therefore we have seen 3 examples here. The first example is the left child of E, right child of E, as well as parent of E, this node. Okay, the next example is the left child of B, the right child of B, and the parent of B, this example, and then the left child of F, right child of F, and parent of F, right? And we could represent all this using an array. So binary tree representation can be done using an array, but we need to be careful that we have a complete binary tree. Only if we have a complete binary tree, we would be able to represent a binary tree in the form of an array. That is a very important point. I repeat one more time. Only if we have a complete binary tree, we would be able to represent a binary tree in the form of an array. Right? I hope you have understood this lecture. Meet you in the next lecture. Thank you.